Hello. So we are back, finally Friday, yeah? And we have a job from one of the subscribers, okay? So it's important to fix this. I took the screws out. So the customer tried to fix it, and I believe he replaced the charging port. Let's check. Is this big ribbon cable and the charging port? And he said it's not working. Actually, people trying to fix their things. This is called progress, okay? They try to learn. I took the screws out, but I haven't checked anything, yeah? Nothing. So first, let's say what the... Let me grab the charger and see what my USB is saying, yeah? Let's see, it's charging, it's not charging, what is going on? And it's doing nothing, we have no line, nothing. Like it's dead. Hmm? We have one more here. Oh, on the other port. But the voltage which is set up by the board is only 5 volts. And it's around 20 milliamps. That's how much it's drawing down. Good. It's not good actually, it's bad, but let's see why. Let's get the multimeter. Let's check the battery voltage first. 0 volts. Let's come with the power supply. This is a big battery power supply, yeah. .6 volts. So let's lower the voltage to around 12. Let's lower the current around 2 amps. Plus, minus. The idea is I can see some light behind. I was seeing some light. Look, and I have some light here. The idea is to charge the battery, yeah, to split the fault, yeah. So you have the input circuit, charging port, charging management chip, because this is a USB-C, and then you have your main power rail, yeah. And the other circuit is the battery. Then from the battery is coming straight to the main power rail, yeah. So if you charge the battery and the laptop is working, that means your input circuit has a problem, okay. That's the reason why I'm charging the battery. I can see some light here. You can see the light. And the fan is spinning. So that's the reason why I'm charging the battery, just to see, and it's working. Okay, seems like it's no hard drive. Probably he took out the hard drive. Okay. But that's the idea. So as you can see here, the board is working fine. Yeah. So we have a problem with the input circuit, with the voltage. It's a little bit complicated. USB-C is not like a normal. You have the V bus, and then you have the middle pin. You have one pin. The board. It's a chip on the board which is negotiating with the charger the voltage, the current. Okay, so it's a little bit more complicated. Now let's plug the charger again because we have some power on the battery. Let's see, the being the battery very low was a reason to not charge. And no, that's not a problem. We still have 5 volts and 20 milliamps, which is nothing, literally. So still not working. Here is not coming on at all. Okay. Well, let's plug the charger. I can see a fuse here. You can see that fuse there? Small white fuse. Let's see, multimeter on screen, yeah. And we have 5 volts, the fuse is good, so the 5 volts is passing, and we have to find the 5 volts here also. Just have a look for the big trucks, yeah, and I can see some big trucks. Look, here are 2 big trucks. This is one, we has a lot of pins, and this is another one. So one must be ground, one must be plus. Okay. So this one has no voltage, so must be ground, and this one has no voltage. Okay, that's a little bit too. That's a problem. So here you have no, you see all those trucks here. This is one truck, yeah, and also it's going to the capacitor. And these pins all together, this is another truck, yeah, and I still don't have voltage. Maybe I haven't kept the ground on the right place. No, nothing. We have no voltage. So here or here is 0. So why that happen? Because this is a big ribbon cable. Look, it's a big ribbon cable and it's coming from here. Yeah. So what happened with those voltages are not leaving the board? Let's follow the power rail, yeah. But look, this is the input. Okay. I'll keep the ground in one place. So we have the input from the USB-C port. Okay, it's coming to this fuse. This is a fuse. Yeah, you have 5 volts here, 5 volts here. Here we have a 5 volts, and from here the truck is going somewhere. But make me believe actually the truck is coming here. Yeah. So look, this is the other USB port. Okay. And we have this chip, and then we have this truck, which you can see separately from the ground truck. Yeah, this is the ground truck. This is the other truck. Let's see what we have on this truck. On this truck we have 0 volts. Sorry. On this truck we have 0 volts. This truck is ground. So let's have a look on the original board, because the man replaced the board. So that's the original board. Let's see, so we have the same thing, and the truck is going on the other side of the board. It's going where? Here. And from here, nowhere. Okay. Most likely that truck is coming here. Look, you have the capacitor here. So this truck must be the plus one. It's coming here, and it's coming here. Okay. So what I will do, let's try and plug the charger on this one. Let me switch. So I plug the USB charger here. Let's take this ribbon cable out. But the good thing is, actually the main board is fine. Oh, but this is not, oh, I open myself now? Or was not close? Was not close? No, it's same story. But actually I don't need that, because I have the other ribbon cable. So I'll unplug this, yeah. I'll unplug this. I'll use the other ribbon cable, which the man said he replaced it. Okay. Let's plug this here. Let's plug this on this. Let's plug the charger. And the same story, yeah? So it's exactly the same. 5 volts should be 19, keep in mind, yeah? And the current is like 20 milliamps. This should be over 1 amp. Yeah? So we do have a problem. Now let's have a look one more time. Did the board is taking any voltage? This is damaged. This is a connector which is damaged. Let's see. Here we have nothing. Here we have nothing. Okay, let's have a look on this board, on this side. So we said on this capacitor must be the main power rail, and it's not. Have 0. And look, you see this chip? Actually, this is doing all the thing, yeah? Like negotiating the voltage, the current. But it's like nearly impossible, like to have 2 boards and both be faulty. Yeah, nearly impossible. One more time, here we have 5 volts. We have 5 volts. What do I want to check? I want to check if the plus of the both I'll use my beeping multimeter. I want to check if the plus of this is going to the plus of this, and it's not. So somewhere must be something which can control the voltage, like a MOSFET, like a chip, like anything. Yeah. So let's pay attention where this track is going. Yeah. This track clearly is going on the other side of the board. Okay. But this plus track, you can see, is coming to this chip. Okay, so you know what I will do to simplify the things, because the voltage can be missing from different reasons. Like let's say your power rail has a short, then the input circuit, it will cut down the voltage to protect the circuit. Yeah. So I'll come with the power supply. Let's set up to 5 volts only, and that will come with the voltage. Yeah. Here on this capacitor. This one, when I said this has to be a power rail, yeah? Minus, plus, and it's taking nothing. My power supply is good, and it's taking no power. So it's not short. We can assume this chip is good because we have a second board. It's quite hard, like the both chips, to be burnt. So what you will do in a case like that? Huh? What you will do in a case like this? You'll say, sorry, you are looking on the wrong place, because you already have another board, so it's impossible like 2 boards to have same fault. And you are kind of right. Kind of. 5 volts. Let's check the voltage on the battery. You know, this is something what I hate, 0 volts on the battery. Let's charge the battery. I don't like it. I can see the light on, so probably the laptop comes on. 7.2 volts, 2.4 amps. So I can see, yeah, nothing changed on my meter, but I have the orange light, like low battery orange light there, yeah. But here we still have the 5 volts. It will not charge with 5 volts. Zero volts. This is something what I hate, yeah? 0 volts on the battery. I don't want to repair a board with 0 volts on the battery. Let's see if the battery is charging, if it's not plugged in. Or even better, let's try to see what power the board is taking, yeah? Yeah, ground plus, and the board is taking nothing. Oh, sorry, that's not the power supply. 50-60 milliamps. So the board is not shorted or something like that, no. And now we cannot charge the battery separately, but yeah, we can. Let's charge the battery. Okay, I admit that this is a tricky fault. Yeah. So everything is good, but it's not working. What do you think about this? Hmm? Plug the battery. And the charger is flashing. Look at the light of the charger. It is not charging. 5 volts. Let's have a look on this chip, yeah? This looks interesting, this chip. because we have to find why this chip is not working. ES A743A, yeah. Parade, yes. ES A7 A743A chip. Okay, this it's a USB-C, USB 3.0. Okay, so usually this is working with the other ports, yeah? With the other, sorry, like display thing is processing the display. But it's doing something else. So possible this is not our chip. But no data about this chip. No schematic also. Let's have a look on the other side of the board, yeah? Let's assume the board and the ribbon cable is good, which probably it is. Let's see what we have on the other side, yeah? You know, are things which are not... I cannot find a link. So this fault should have like a probable cause, yeah? I mean, why this board got faulty? Hmm? What's the reason? Has to be a reason. So what's the reason? There's the screen, and the screen is good. The Funnies has an interesting design. So the board cannot be taken out from here, should be from here. I mean, something is faulty. It's not about resetting and BIOS not working or things like that. Yeah, something is faulty here. But what? Because the laptop, it is coming on if you charge the battery. So what's the reason? Something is holding this board in place. But what? Huh? Something is holding this board in place here. And I can't see anything. So here is holding, okay, I think it's only a plastic thingy. Oh, come on, this is the heatsink is from here. Okay, I suppose this laptop probably it's expensive. Like the way how it's built. Must be expensive. I think we have to take out the battery. My coffee. We no sugar. Oh, the screw is missing here. This screw is missing. Oh, look at this. Someone took the heatsink out. This is the power management chip. Most likely that is the problem. Probably this is a Super I/O. But what I can fix here? Because I can't see anything what I can fix myself here. Wow, this is really insane. Ah. Oh, I don't even know from where I can start. This is a big power rail. Nine to 3. What is 9 to 3? As a processor power supply. Or not? No. It's a driver. This is sick complicated. First, let's start with the basic, yeah? What's this? This is a humidity sensor? Must be. If that's a humidity sensor, no, no way. It's some test point, okay. Okay, let's check those test points, yeah? I'll get my beeping multimeter. This is good, it's not short. This is good, this is good. This is good, this is good, this is good, good, good. All are good. There is nothing shorted here. The problem is this chip, probably it's working partially because with the battery the laptop start working. You see, this is a hard job. This is a proper hard job. When everything is good, yeah, and also you have spares, yeah, but it's still not working. This is an insane job. Okay, okay. Let me find where the plus is going. So let's see. That's plus, that's plus. Okay, it's more complicated than I thought. Yeah. There's more. So this is a plus. This is ground. Oh, this is insane. A plus. Yeah. This is crazy. Give me 1 second. Look at this nice small heatsink. It's nice. So what I'm doing, I'm following the voltage pin from the input. And actually the voltage pin is coming straight through this ribbon cable to this track. But I don't know where it's going from here, yeah? But we will know soon, yeah? So actually on this capacitor what I said, this is the comeback voltage for this, yeah? So it's charging only on this one. So this track from this fuse is coming somewhere here. Probably some input MOSFETs. Because this big coil, I believe is the MacBook style, is creating a voltage for the motherboard. So the main power rail probably is created by this coil. You know, I can't see this voltage coming here. So from here, yeah, it's coming here. You can hear the beeping. But from, I don't know where it's going. So I don't know where it's going from this pin. It should be going somewhere here. One of those MOSFETs. It's like it's going nowhere. I mean, how this is possible, you know? Like the voltage track is going nowhere. Like nowhere. Nowhere. You know what I'm afraid? I'm afraid that actually this track is going under the chip. That will be a big problem. Do you understand the plus? Like the charging port plus, which is this, is going somewhere. But I cannot follow the track till here. Here, it's coming here. I can hear on the beeping thingy. Yeah, it's no ground. It's coming from here. I don't know where it's going. It's like this. It's disappearing. Like it's. And here are like 4 or 5 pins on the connector. It's going somewhere, but I have no idea where. I mean, it's a 19-volt track. It should go somewhere. And the only way where this truck can go is probably under this chip, but it's weird because she'll go like to have like a capacitor or something, like anything, like, but it's like a dead end, like it's going nowhere. Nowhere. Okay, let's change this thingy.
That's all I said. From now,
Hmm? So what you'll do in this case, if you have a job like this? Because I'm curious to see how the other people are doing this kind of stuff. So what do I want to do? I want to solder a wire on this board on the plus and check properly to find out where that truck is going. Because that truck is very, very important. That can show us a lot of things. It's impossible to find a wire. Yeah. Found it. Okay. Let's see now. So we have our beeping thingy. Yeah. It's coming here and it's good, it's beeping. Yeah. And from here it's just disappearing, you know, it's like nothing, it's gone. Most likely it's going on this side, yeah? I'll change on the microscope, but I cannot concentrate to have the picture on the screen. Because I have to pay attention here. There is like nothing. Nothing. is here. Ah, I found it. Yeah. So this is my first MOSFET. Yeah, this is my first MOSFET. Then this is my second MOSFET. And then we have the current sensor. I found the little bastard. Okay, so let's come with the power supply. Yeah. Let's go with 5 volts only. Yeah? 5 volts. Yeah. No nicio problema.
Charging port to nu merge. Încarcă dacă nu-i dă drum.
Ce iPad e?
iPad 5th generation.
E sigur că ne dai?
Nu e, că am verificat.
Așa putem face.
Cât costă și
100. Da, probabil săptămâna viitoare. Okay, and it's taking no current. Good. Now let's go with the multimeter. I'll use the on-screen multimeter. And the on-screen one has 5 volts, good. Then on the output, we have 5 volts. Then on the current sensor, we have 5 volts. Current sensor, 5 volts, good. So this is working. So from here, okay, from here, it's making up the. Okay, you know what? Let's take 1 second because I seen something on the board. What's that? What's that? You see that diode? That looks like a blow-up diode. What happened with this diode? What happened with this diode? Can a small diode make the laptop dead? So here must be a power rail, yeah? Let me take out the power supply. Here must be a power rail. For a simple reason, we have a big resistor there, yeah? Let's switch to Diode Mode on the on-screen multimeter. Yeah, we have this big resistor here, which is not showing me nothing. It's like 0. Oh, it is 0. Sorry. Then we have 2 diodes, yeah? And the diodes are in a parallel mode, so the plus of this diode comes with the plus of this diode. I can't see. So the plus of this diode come with the plus on this diode. So we can assume those diodes are in parallel mode, yeah? Now parallel mode, and it's not showing me like it's shorted. And this one is not shorted. Okay, well, let's remove that diode and see what's going on there. Because that's a good start, otherwise I'm like out of idea what to check. I mean, that's the worst case, yeah? When everything, like everything is looking fine, but it's not working. Like whatever I checked here looks fine. I can't take it out. Bro, this is welded. It's crazy. Yeah, diode is welded. No, let's... Huh? Okay. Let's see what this diode is doing, yeah? Let's compare with the ground first. So here is no ground. Here is kind of ground. Wait. Here is no ground, here is ground. How can be plus on the ground then? Only if those diodes are sending something to the ground, yeah? This is 0. Let's see what's happening with this resistor. This is 0. What about these things are together? You know, I believe we have a divider with diodes. So here we have like in a MacBook, you know, you have one power rail coming from this diode, and you have another power rail coming through this diode. They meet here, and from here it's a power rail, which is looking like it's on the ground. Here is ground, but it's not supposed to be ground because here you have a capacitor, and the other side of the capacitor, here you have ground. Yeah. So on the other side of the capacitor we have ground, and here we have like 6 ohms. So on this power rail something is shorted. That's the reason why that would blow up. Okay. So what can be shorted on this power rail? It's not hard to find because you can see the truck is coming straight to the chip. Even that diode doesn't look good. I swear. But look at that diode, has a hole on it. But it's not short here. Here is no short. Okay, let's go with the power supply. Let's lower the voltage. Like 2 volts. Just to be safe. Now let's come with the voltage here on the capacitor, and it's taking 500 milliamps. Let's use some petrol to see what's going on here. Yeah, I can see, but you can't see. Yeah, so pay attention on that chip. Yeah. So what do you think is the problem here? Here is ground, yeah? Here is plus. What do you think is the problem here on this laptop? Look at that chip. And it's like only 500 milliamps. But the chip is shorted. You can see how the petrol is moving on the chip. That's because it's releasing a very high temperature. So what chip is this? What is doing this chip? Yeah, this is more important. What this chip is doing? So this chip, it's a A237HRZ. A23, no, 923, sorry. 923 7 H R Z. ISL 9237. Okay. So what the chip is doing? Buck Boost Narrow VCC battery charger with SM blah blah blah. Okay. I think we found our problem. This is a cool chip. Look here, look on this configuration. Yeah. What reminds you this configuration? You remember the audio bridged amplifiers? So basically you have one amplifier here, you have one amplifier, and you have the speaker in the middle, yeah? But this is not a speaker, this is a coil in the middle. Yeah. And this is not the plus. Here is the main voltage, but here on the other side probably you have the voltage output. So these two are switching, yeah, are switching this coil, yeah, like each one time. When this is on, this is 0, yeah. When this is 1, this is the other one is 0, and it's switching this coil like hell. This is a nice chip. How much it will cost? You can find it on eBay. eBay, like 10. From Romania, Timișoara. Okay. So we can order this chip. This is from China. What about UK? We can find this chip in UK. I don't think I have this chip. I don't think it's even point to check if I have this chip. From Romania. This one is England. Patsy. Okay, so I can order this from UK. It's like £5. Wow. So we can fix this laptop. So now you understand why I did try to understand the input circuit, because it was clear, yeah, Like, I have to find what's happening with my input voltage. That was the idea. And this chip is the driver of this big coil, which is creating the main voltage. And obviously, it's doing probably morphing, communicating with the USB-C and more. Let me see if I can find this chip. I have some new boards here somewhere. But this is a long story. So searching for that chip on my boards, it will be a really, really long story. You know what I will do? I will stop this video and I'll order that chip. But the name is so I'm so familiar with this chip name. Let me see. I do have few second-hand chips here. BQ. That's something else. This is something else. This is something else. This is something else. One 2 5. Nine 5 A2 6 HRZ. 958. No, it's 92. Okay. Close. Very close. Very close. No, clearly I don't have that chip. Now just try to ignore the fact this video is 1 hour and 13 minutes trying to diagnose and find the problem. And we found the problem. We replaced the components. But it is not only about making money, it's about you are left holding this knowledge. Yeah. So on the next job, like this laptop, you'll know already, yeah, that's the chip which is managing the input voltage. Okay. Then we have the diodes. Well, I'm sure we can find here two diodes if are normal diodes. If are non-normal diodes, we will have a problem, yeah? Because how we can know what diodes are, you know? But that's easy to figure it out, yeah? Okay. I mean, so based on the configuration, really looks like a normal diode. But even that, the other diode has a hole on it. Yeah. So I suppose you have to replace the both diodes. Let's try and figure it out together, yeah? Because I'm not convinced what I said earlier, like is like the same with on the MacBook. When you know where you have that double diode, if you've seen that video. So it's diode mode. This diode is here, yeah? And here is 11 ohms. So here I have 0. Okay, so it's not the same track. It's not the same track. But looks like it's the same track. No, but it's not. No. This, wait. This is ground. This is that voltage. And this is something else. So you see, this is another power rail. This have nothing to do with this. This one. So the plus of those diodes, yeah, it is like another MacBook. The plus of these two diodes goes to the chip. Yeah, goes to this capacitor 0, 0. Sorry, I'm on the ground right now. So this comes here, yeah, on this side of the capacitor, here, and then comes to the chip on this pin. And this no, this is not coming from here. This is coming here. So the voltage result here comes through the resistor and is coming to the capacitor, okay? So this resistor is in a serial mode from here. So here we have one voltage which is coming through this diode here, and here we have another voltage which is coming through this diode here. And the voltage mixed together here and goes to the chip, okay? It's like a case when you, like on the MacBooks, when actually you have the voltage, you have a low voltage which is coming to detect the charger when it's plugged in, and the other voltage is coming from the battery. They meet together through these two diodes, yeah? They are using diodes so the voltage don't go on the other side, yes? So you have two diodes and you have a one power rail where actually you can there you have voltage whatever it will be, yeah. So let's say your battery voltage is dying, you still have voltage from the charger. Your charger voltage is not present, you still have voltage from the battery. That's why they are using this kind of you know what I mean, yeah? Okay. But yeah, I suppose, yeah, let's say just supposing that diode was not exploded, yeah? Most likely I will take that chip and I will check what it's doing on Google, and on some point I'll replace that. Maybe I'll not replace it. I will check his power supply, yeah, because he is shorted. So even if I will not see that diode, it's probably on some point, but spending a little bit more time, I'll find that that chip is actually shorted. Okay, so I'll stop this video here. See you on the next one, yeah, when I will order the chip, when I will feed the chip together. Okay, what laptop is this? Maybe you'll have this problem because this should be a common fault. It's happening on the main power rail. This is a Lenovo Yoga 910. Okay, keep in mind if you have this problem. So I'll order the chip and we'll replace the chip together next time. Thank you for watching. Like and subscribe if you like the video, and enjoy your weekend. Bye.